Hey guys, and welcome to this lesson all about solving rational equations. And what do we mean by rational equations? Well, they are equations, so we have equal signs, and we are solving them. We're trying to find a value or values for our unknown variable that make the equations true or balanced. What makes them rational equations? In particular, we're dealing with rational expressions, so ones in which we might have polynomials in our denominator. So that's the kind of defining feature of a rational equation. And I want to talk first, in this first example, about a type of equation we may have seen before and how we dealt with it to kind of motivate the strategy for solving some more complex ones. Earlier in the year when we were dealing with equations, we saw what I think to be much nicer equations, something like 2x minus 5 equals negative 9x plus 17. All nice integer coefficients, nice integer constants. Everything is very clean, very user-friendly, if you will. And I hope you feel very confident solving an equation like this. Now, what's the difference between this equation in blue and this equation in black? Well, I think we've got a fraction coefficient here, a fraction coefficient here, and a fraction constant there. Are the strategies going to be exactly the same? Well, technically, yes, but fractions are more difficult than integers, or at least I believe so. So my question is, how can we take this equation right here, which has a whole lot of fractions, and kind of transform it into an equation that's, of course, equivalent, but maybe without so many fractions and all integers? And so I want to draw on a skill we may have talked about earlier called clearing fractions, in which you multiply the left side of the equation and the right side of the equation by the same number in such a way that you don't have any fractions anymore. Now, what number should we multiply by? Well, I think the easiest number is going to be whatever the least common denominator is of these three denominators. Because if you multiply that number, which in this case I think is 24, if we multiply the left-hand side of this equation by 24 and the right-hand side of this equation by 24, I hope you can see already that we are going to have no more fractions left. This 1/2 will simplify to a 12, negative 3/8 times 24 will be negative 9, and positive 5/6 times 24 will be positive 20. So let's go ahead and actually do that and show the mechanics of how that looks. We'll do it in hot pink, if you will. So we're going to multiply the left-hand side of this equation by 24. We're going to multiply the right-hand side of this equation by 24. I like to go big with the parentheses to really remind myself that I'm going to need to distribute this 24 and distribute this 24 and not lose sight of that. So 24 multiplied by 1/2 x, well, I think that 24 times a half is 12. So we end up with 12x. 24 times 4 is 96, plus 96 equals, 24 times negative 3/8 x, I think is going to be negative 9x. 24 times positive 5/6, I think is 20. So check it out. By multiplying both sides of the equation by the least common denominator of these three denominators, boom, we have cleared the fractions. We are left with only integers. I'm feeling really confident about this. Let's go through the motions of actually solving it. I think I'm going to go ahead and add 9x to both sides of this equation, yielding, again in hot pink, 21 times x plus 96 is equal to positive 20. I'm going to go ahead and subtract 96 from both sides of this equation. And I think we are left with the new equation, 21 times x equals negative 76. And from here, we're almost home free. We're going to go ahead and divide both sides of this equation by 21. And we find that our solution in this case is that x equals negative 76 over 21. Certainly not a very nice looking solution, but I do have to believe that multiplying both sides of our original equation by this least common multiple of our denominators left us with a very clean and much easier equation to work with. And so that's the kind of theme or the strategy that we're going to use here. Now note, in this example, all of our denominators were constants, 2, 6, and 8. Let's take a look at our next example. And note to self here, this number 4, it doesn't have a denominator per se, but you can think of it as a fraction of 4 over 1. So the denominator here is just 1. In our second example, I see we've got some fractions again. In this case, our denominators are, well, 1, x, and x squared. And I hope that we can agree that the least common multiple of 1x and x squared is actually just x squared. So we're going to go ahead and we're going to multiply both sides of this equation by that least common denominator, x squared. And I hope you can intuitively see why when I multiply 1 by x squared, 6 over x by x squared, and also, I should call my dad. Good point. And also 16 over x squared by x squared, we're going to have some simplifying, I'll even say canceling out, we're going to have all integers left. So x squared times 1 is, not surprisingly, x squared. X squared times 6 over x. I'm going to actually go ahead and kind of write this out. We'll have 6x squared over x. And note to self, we're going to have some simplifying. We'll end up with just 6x to the first. Oh, also known as just 6x. And then last but not least, x squared times 16 over x squared. We're going to have some simplifying right here. X squared divided by x squared is just 1. So we end up with 16. So ultimately, our equation has transformed into this nice, very clean polynomial equation with all integer coefficients. And I hope you remember how to solve this. Right, here is a polynomial equation, and our number one strategy for solving such an equation is to do so by factoring. So first things first, I'm going to obtain a 0 on one side of our equation. And let's try to factor this polynomial right here. I think it does factor cleanly. Do you know how it factors? I think it factors as x plus 8 times the quantity of x minus 2, meaning that our two solutions are either x equals negative 8 or x equals positive 2. And these are the two solutions to our original equation right here. And you can go ahead and you can actually substitute these numbers in and see that they actually do work. I think this original equation with all the fractions was kind of tough. But once we cleared fractions by multiplying by the least common denominator, I think we ended up with a very nice clean equation. And that's the idea. I mean, that's the strategy we're going to use. So all of the remaining examples, nothing new with regard to strategy, just a couple different iterations of it. All right. So in this next example, a slightly similar looking equation, but not 100% the same. What is the least common multiple of these denominators here? And one thing I will note is that this denominator right here, it's a little bit easier, I think, if we factor it first. And so I hope you know how this factors. This is a common factor of p. We're going to multiply this, or rather rewrite it as p times p minus 4. And I hope now that looking at these three denominators, a denominator of 1, a denominator of p, and a denominator of p times p minus 4, I hope we can recognize that this right here, this is our least common denominator, or the least common multiple, p times p minus 4. So I would always factor your denominator if you can. So let's go ahead and do it. All right, so we're going to multiply the left-hand side by that least common multiple, so p minus 4. I'm going to be really diligent with my parentheses and brackets in this case. And the right-hand side of the equation, we're going to multiply by the same thing. We're going to use a little copy-paste action. Okay, this I think is the most difficult part of the whole process. Well, when we multiply by 1, life is good. And in fact, I'm just going to write that left-hand side as p squared minus 4p. Okay, the right-hand side, this is a little tough. What happens when we multiply this by 1 over p? Well, I think this p divided by that p is going to be 1. They're going to simplify away. We're just going to end up with p minus 4. And now I'm going to try and erase. There we go. And when we multiply this by 2 over p squared minus 4p, well, I hope you can see that these are going to simplify to 1, right? This part of the numerator is going to simplify with that part of the denominator. Boom, simplify to 1, we just end up with minus 2. All right, and what do we have on our hands again? A nice polynomial equation that we're going to solve in the exact same way. We're going to try to factor it. I think this step of actually multiplying both sides of the equation by this expression is the hardest. What cancels out? What simplifies? What doesn't? How does it work? We got to keep track of the distributive property, for instance. Okay, well, let's go ahead and actually solve this. So I think we've got p squared minus 4p equals p minus 6. Let's go ahead and subtract p from both sides of the equation. We're going to do this one step at a time. P squared minus 5p equals negative 6. Let's add 6 to both sides of this equation. Remember, we're trying to solve by factoring, so we need to obtain a 0 on one side of this equation. Boom, boom, boom. There you have it. How does that factor? I hope you know how that factors. That factors as p minus 2 times the quantity of p minus 3, meaning our two solutions are that p equals positive 2 or p equals positive 3, and those are the two solutions to our original equation up here, which I think looked pretty hard to solve at first, but with this nice clearing of fractions, we had a nice simple, or simpler, polynomial equation. All right, I think we have two more examples coming up. You might want to pause the video and try them on your own, but I'm going to walk you through these two anyway. They just get slightly more complex. Same idea as before, we need to find our least common multiple of these denominators. And I think it'll be a lot easier if we go ahead and factor this denominator right here, which happens to be the same as that denominator right there. I hope you know how it factors. It factors as x minus 5 times the quantity of x plus 1. So I hope it's clear that this right here, this is the least common multiple of our denominators. So we're going to multiply both sides of the equation by that least common multiple. All right, we're going to make it all orange. And we're going to put some brackets around it. We're going to do a little copy pasting action here. Gotta love it. We're going to multiply the left-hand side of this equation by that. We'll make it a little smaller. Left-hand side of the equation, and we're also going to multiply the right-hand side of the equation. Definitely want to be diligent with our parentheses. Don't want to forget anything. Okay. Woo! So I hope we can agree that when we multiply by this term, all of this simplifies to 1. So we end up with just 5x plus 3. All right, so 5x plus 3. Woohoo! Making moves. When we multiply here, only the x minus 5s are going to simplify to 1. And we're going to end up with x plus 1 multiplied by x plus 1. Now I hope we know and can do mentally what x plus 1 times x plus 1 is. That's x squared plus 2 times x plus 1. And on the right-hand side of our equation, similar to before, when we multiply these two, all of this is going to simplify to 1. We end up with just 4. All right, and again, boom, we have a polynomial equation here. I certainly hope that you know how to go about solving it. All right, and we find that the two solutions to our original equation were that x could equal 0 or x could equal -7. Okay, only one more to go. Let's do it. Very similar to before. All right, what is the least common multiple of these three denominators? Let's go ahead and factor this more complex one to begin with. I hope you know that that factors as a plus 5 times the quantity of a minus 6. Again, it happens to be that this right here is the least common multiple of these three denominators. So that is what we're going to multiply both the left and right side of these equations by, or this equation by, excuse me. So we're going to multiply the left-hand side by that. We are also going to multiply the right-hand side by that, making sure to add in our parentheses, appropriately. All right, on the left-hand side, when we multiply these together, the a minus 6's are going to simplify to 1. We end up with just a plus 5 times a minus 4, which I hope we know is going to be, let's see, a squared, a squared plus 1a minus 20. The right-hand side, okay, this is going to be tricky. When we multiply these together, the a plus 5's are going to simplify to 1. So we end up with just 1 times a minus 6. So just a minus 6. Let's get rid of the rest of that stuff. So just a minus 6. Okay, not so bad. And in our last step of multiplication, when we multiply these together, all of this will simplify to 1. We just end up with 2. All right. And once again, boom, polynomial equation. I'm feeling pretty confident in your ability to go ahead and solve this one. All right, so now that we had this nice polynomial equation, we found our two solutions to be that a could be -4 or a could be +4. So that is the general strategy for how we're going to solve these rational equations. Just find that least common denominator, use it to clear our fractions, and we're going to have a much nicer, often polynomial equation to deal with. So, hope you found that helpful, and I hope you enjoyed.